Okay, if we look on the board, everyone has the same correct answer, 27.5 grams of sodium chloride. Looks like everyone on the board did this all in one big long step. When I was writing it in my notes, I did it in 2 steps. And I'm only showing my copy because I'm videotaping this and I want to show the answer. So we know the concentration of sodium ion is 1.08 times 10 to the 4th milligram per liter of sodium ion. 1 gram is 1,000 milligrams. And we have 1 liter, so that gives us 10.8 grams of sodium ion in each liter. And I just did the quick and dirty, 58.44 grams of sodium chloride per 22.989 grams of sodium gives me 27.5. Many of you on the board went through the mole to mole ratio, and that's the more logical writing everything down way. If you did it the shortcut way, just looking at the gram ratio, that's fine too. And you may feel more comfortable with that as you go on and move forward with this. So now we want to look at conversion of one concentration unit to another. So when we're looking at these units, we now have a lot of units in our arsenal. We have molarity, molality, all kinds of percents, parts per million. But we often need to change from one to another because the property we're looking at requires a different unit. So we have to really think about this. There is nothing that you can memorize when you're looking at these kinds of problems. You have to face each one individually, think about what information do I have and what information do I need. So we're going to go through the first one where I've kind of outlined the steps. This is one of the hardest ones because in this problem we are asked what is the molality of 1 liter of a 1.5 molar solution of bromine in carbon tetrachloride. The density is 1.85 grams per mil. This is the hardest type because it includes molality. And we have molarity. We have moles of bromine per liter of solution, and we want to get to moles of bromine per kilogram of solvent. So when you look at this, the moles of bromine part is easy because that doesn't change. But changing liters of solution into kilograms of solvent means somehow I have to get rid of the solute out of there. And we know we can use density to change liters or milliliters into grams, and we can change grams to kilograms, but this is solution and this is solvent. So that's what makes the problems with molality the hardest ones. Okay, let's look at how we do this. We start off by finding the mass of solution using the volume that I have, 1 liter, and the density. So I know that I have 1 liter of solution. I know that 1,000 milliliters is 1 liter, and I know the density is 1.58 grams per milliliter of solution. So I have 1,580 grams of solution. Now let's figure out how much solute is in there. I know that in this 1 liter, I have 1.5 moles of bromine dissolved in my 1 liter because it's 1.5 molar. And I grab my periodic chart, 159.8 grams of bromine is 1 mole. So that's equal to 240 grams of bromine. I can only keep 2 sig figs here. Now I know the mass of the solution, I know the mass of the bromine. Now I have to subtract. And this is the weird part when you're going in and out of molality. You'll either subtract if you're going to molality, or you will add the mass of the solvent if you're going from the molality. So find the mass of solvent. 1,580 grams of solution minus 240 grams of bromine, which is my solute, gives me 1,340 grams of carbon tetrachloride, my solvent. So now I know the mass of solvent, I know the moles of solute, now I can find molality. 1.5 moles of bromine in that 1 liter sample divided by 1,340 grams of carbon tetrachloride, my solvent. 1,000 grams is 1 kilogram, so I get 1.1 moles of bromine per kilogram of carbon tet, 1.1 molal. Now, when you look at this, the molarity was 1.5. 1.5 molar, it's not the same as 1.1 molal. So there is a statistically significant difference in those two numbers. And that comes about because carbon tetrachloride is so dense. If this were in water, what would you expect to see between the numbers for molality and molarity? Yeah, they'd be almost the same, right? They'd be really close because if the density of the water is 1, the density of the solution wouldn't be much different. And so when you have aqueous solutions, molarity and molality are really close to the same. Okay, let's have you go ahead and just try this next one at your seats. Go ahead and do that one at your seats.